Intro Algebra Lesson 2-6B. Continuing our discussion is dealing with distributive property and positive and negative numbers and terms. We've got our first concept here known as a coefficient. And a coefficient is going to become important because that's what we'll use to look at to determine when we add like parts, another thing that we'll be looking at, whether or not we want to put things together with positive and negative numbers. So in a term that is the product, and remember product means multiplication, of a number and a variable. So anytime you have a number next to a variable, that's product. The number is what we would refer to as a coefficient. So as an example, if you had a number being multiplied by a variable, since this is multiplication with no operation sign, the 5 is the number, that's the coefficient. It's the number in front of the variable. If you had a whole bunch of them, you could have a number of coefficients. It's whatever the number is in front of a variable. Now, like terms, we've talked about terms in an expression, or the parts, the chunks being added. All right, and we can change subtraction into addition. Now, for terms that are like, or like parts is another way of saying this, like parts. Like terms, like parts, they have to have the exact same variable or variables, and they have to have the same exponent, meaning if one of them is squared and there's another term that has the same letter but it's not squared, they wouldn't be considered like parts. So here are some examples of like terms. 4x and 10x. They both have the same variable, and you notice that they don't have any exponent. They have an exponent of 1, but we don't typically write that down. The 4 and the 10 don't have to be the same. The coefficient doesn't have to be the same. The variables have to be the same. 3b squared and 7b squared. They both have b's, and they're both to the power of 2, so that would be considered like parts. 6df and 8df. They have the same number of variables and the same kind of variables to the same exponents. If this were df and that were fd, that wouldn't matter, because we have commutative property of multiplication. This would be an example that's not like parts, not like terms. And you'll notice they both have x's, but this x is squared and this x is not. So that means they're not like parts. They would not be considered like terms. Now, in order for something to be considered simplified, and from here on out we'll be looking to simplify equations and simplify expressions. There can't be any grouping symbols, no brackets, no parentheses, nothing, no grouping symbols, and all the like terms have to be combined. Now, unfortunately, sometimes people go too far, and they simplify and they add like parts that truly aren't like parts. They add terms that are not like parts. So you have to be careful of that. Now, what is more simple? 4r plus 3 plus 5r, or 9r plus 3? This is more simplified down. Now, if you look at this, the 4r and the 5r are like parts. It's all addition, so you can add in any order you want. 4r's and 5r's makes a grand total of 9r's. The 3 does not have an r, so it cannot be combined. It's not a like term. So we're left with this expression in simplest form. No grouping symbols and no like parts that can be added. Unfortunately, people try to take it a step further and they say 12r, but they're not like parts, so you can't combine them. Alright, here's another situation. Negative 1g and negative 6, or negative 1 with g plus 6. Which of these would be in simplest form? The one on this side would have to be in simplest form because this one has grouping symbols. We're not allowed to have grouping symbols if it's truly in simplest form. So how do we get rid of the grouping symbols? We use the distributive property. And the number on the outside would get multiplied by both the parts inside, and that's where negative 1g and negative 1 times 6 is coming from. So those are in simplest form. This would be in simplest form, and this would be in simplest form, because all the like parts have been combined. So let's try some out. 4x minus x. Very common for someone to say, oh, I know the answer. The answer is 4, because I just take the x's away. You've got to be really careful at this point. You can't do that. What I would suggest is that anytime you see a variable alone, put a 1 in front of it. That's for starters. Now, I still go back to changing subtraction to plus the opposite. Now they have the same terms, the same parts, which means you can go ahead and do this addition involving the 4 and the negative 1. You can combine the coefficients since they have the same parts. 4 plus negative 1, there are 3 more positives, so the answer to this is 3x. Very common mistake for someone to just say 4, thinking that the x's cancel out. 5x squared minus 7 plus 3x squared. A quick adjustment to plus the opposite now allows us, because of the commutative property of addition, to say 5x squared plus 3x squared plus negative 7, which means these two are like parts. They have the same variable to the same exponent. 5 plus 3, you add the coefficients, gives us 8x squared plus negative 7. Now I'll tell you a very common mistake made on this one as well. People accidentally put a 4 right there because they think they're supposed to add the squareds to get 4, and that's incorrect. You keep the exact same exponent that you have. So be very careful about that. We want to keep it as a 2. Now I'm not going to go any further. I'm not going to say 8 plus negative 7 because the negative 7 does not have an x squared. It's not a like term, not a like part. Alright, a number of signs here. I would again agree to make this plus negative 2x, and I would make that plus negative 4 because that's what you're going to distribute. You're going to distribute this negative 4 to both those parts. Remember, for multiplication, you don't have to have like parts. For addition and subtraction, you do. So the 1's doing nothing. It's just hanging out here by itself. Negative 4 times 1 makes negative 4. And negative 4 times a negative 2x is going to make positive 8x, because negatives times negatives makes positives. Now you have like parts. These parts do not have x's. There are 3 more negatives. And we cannot go any further because there are no more like parts. So it's in simplified form because I got rid of the grouping symbols and I have no like parts. It's as far as it goes. Now you could rearrange it, and you could say 8x plus negative 3. And there's nothing wrong with that because it's addition. You have the commutative property of addition. You can change the order. Negative 4x minus 5x, very common. Someone goes, oh, 4 minus 5 is 1, or 4 minus 5 is negative 1. But if you actually changed your signs to plus the opposite, you'd realize that it's a negative plus a negative, which should make more negatives. Negative 9x. Again, you don't have to change subtraction to plus the opposite, but I find that people make fewer mistakes if they do that. Okay? Here's another example of changing plus the opposite, and when you just have a variable alone, putting a 1 in front of it is nice. Now that it's addition, 3x plus 1x plus negative 4x squared. They are not all like parts. This one has an exponent of 2, but these two do not have the exponent of 2. So these are the like parts. 3x and 1x make 4x plus the negative 4x squared. Now you could leave it like this, but typically the exponents that are bigger we put first. So negative 4x squared would go first plus the 4x. There's not a major difference between them, just an appearance, but we usually try to make the larger exponent work its way down from the right. And our last example, we want to simplify this as far as we can. We have grouping symbols. Very common mistake, somebody wants to take that negative 2 and add 5 to it right now. You've got to be very careful. And unfortunately, people don't deal with this subtraction correctly. A lot of times people have negative 2 minus x plus 5. And there's a big difference between this and what should be done. You have to be careful about it. I'm going to write this off to the side so we can compare what it looks like compared to what it should be. If we do what I suggest, which is to change this to plus the opposite, then I don't want just the opposite of x. I want the opposite of all of this, which means this negative sign needs to be distributed here and here, leaving us with negative 2 plus negative x plus negative 5. Now, compare those two. You'll see that right here, I could have changed this to plus negative, and the negative 2 would be the same, the negative x would be the same, but here's a difference. Not dealing with the signs correctly made this a plus 5 versus a plus negative 5, and that's where the problems usually exist. So please be very careful You actually want to distribute the sign to both of those problems. Now it's addition, you can rearrange it. -2 plus -5 plus -x. You've got like parts. Negatives plus negatives makes more negatives. Typically, we would write the variable first. So we would say -x plus -7. If you want to stick a 1 in front of that x, there's nothing wrong with that. It's the same thing, -1x plus -7. Again, simplest form means no grouping symbols are left, so you have to use the distributive property to get rid of those, and you've dealt with all like parts. That means they have the same variable or variables with the exact same exponent. You've combined as many of those as you can. Don't overgo it. Don't go to this and say, oh, that's -8x. If you go too far and you put non-like parts together, you'll get the wrong answer. And be very careful with your signs. This is where the attention to detail is crucial.